Life cycle carbon footprint of nitrogen fertilizers. Nitrogen fertilizers are essential for sustainable agriculture and enable feeding a growing world population. However, their production, transportation and application emit greenhouse gases. Life cycle carbon footprint assessment allows a better understanding of what can be done to improve the overall carbon balance in order to mitigate climate change. The illustration explains the carbon footprint from production, transportation and application of fertilizers to growing of crops, their consumption, and the protection of forests and natural CO2 sinks. The carbon footprint of fertilizer production is related to energy consumption and nitrous oxide emissions. To reduce the carbon footprint, energy efficiency of production plants needs to be increased and nitrous oxide cleansing technologies to be installed. Fertilizers are transported by ship, barge, road or rail. Transportation contributes little to the carbon footprint of fertilizers. It can be minimized by optimizing the logistics chain from production sites to farmers. Nitrogen in the soil is subject to natural microbial conversion. During this process, nitrous oxide can be lost to the air. Carbon footprint is minimized by using balanced nutrition, tailoring nitrogen application according to actual crop needs, and just-in-time application to ensure rapid nitrogen uptake by the crop. Plants capture large amounts of CO2 during growth. Optimal fertilization stimulates crop growth, increases biomass production, and thus CO2 uptake. Most of the biomass is consumed as food or feed, and CO2 fixation is therefore only short-term. The balance is different for bioenergy since it avoids the burning of fossil fuels. High productivity in food and feed production allows more acreage for bioenergy production. Forests and wetlands store 2 to 8 times more CO2 than croplands. This is why further land use change needs to be avoided. Preserving forests and wetlands and restoring degraded agricultural land is the most important contribution to mitigating climate change. In conclusion, nitrogen fertilizers enhance agricultural productivity and reduce the necessity to cultivate new land. They thus help to avoid additional greenhouse gas emissions from land use change. Sustainable agriculture with the use of efficient, low-carbon fertilizers ensures food security and mitigates climate change.